In number 24, we want to find the equation of a function whose graph may be obtained from that of x cubed by shifting left 2 and reflecting across the y-axis. So we're starting with y equals x cubed. And then we have left 2. So that would be y equal x plus 2 cubed. Okay, right would be x minus 2. And then reflect y means replace x with minus x. So here we're doing reflect y. And just replace x with minus x. (25) A polynomial of degree 10 has at most 9 turning points, one less than the degree. And intercepts, how many intercepts does this polynomial have? Well, intercepts is at most the same as the degree, so 7. (26) Does the equation give y as a function of x? Well, if we could solve for y, then it does. Okay, and we want to solve for y without a plus minus. Okay, so let's do that. So here we have an a. Let's subtract 7x and add y squared. So I just want to add y squared to both sides, solving for y squared. And if we were to solve for y, we would have a plus minus. So then y is not a function of x, so no. No for A. And B, again, let's put y cubed on the right. And on the left, let's say we have 7 plus 2. And y is equal to the cube root of 9, so that's yes. Well, actually, it really would be better here if I had a variable in here, like let's say if I change this to x. Okay, and then we would have y cubed equal to 7 plus 2x, and y equal cubed root 7 plus 2x. Again, the answer is yes, because y could be solved in terms of, we could solve for y in terms of x without having something like a plus minus in front, so that's yes. Okay, 7a. It says, suppose $1,000 is invested for 10 years, compounded continuously, and grows to 1,500. Find the interest rate. So let's write down our continuously compounded formula. Okay, so we're starting with 1,000, 10 years, and it grows to 1,500. Divide both sides by 1,000. Take the log of both sides, ln, let's say. And here we have the rate, ln 1.5 over 10. And that's equal to 0.04, or 4%. Now, part B says, how many years does it take for a $1,000 investment at 5% compounded continuously to grow to 1,500? All right, so again, A equal P e to the RT. So our investment is growing to 1,500, starting at 1,000. And the rate is 5%, that's 0.05. And we want to see how many years it takes. All right, so divide both sides by 1,000. Ln both sides. and divide by 0.05. So we have ln 1.5 divided by 0.05, and we have approximately 8 years. Okay, in 28 we're sketching the graph. Let's remember what y equal 2 to the x looks like. And we're just going to we'll look at transformations. So this is what y equal 2 to the x looks like. This is the 0.1001. Okay, let's move it. We're going to move it because of the x minus 1, that would be right 1, and because of the plus 3, we will move it up 3. Now, we'll do this in one graph. Here we have this horizontal asymptote, so that moves up to 3. And this 0.01 is going to go right 1, so it's going to move 0, 1. Let's just write where that goes to. We're going to add 1 to the x and add 3 to the y. So 1, 4. Right there. And we'll just basically copy the graph over. So that's the horizontal asymptote at y equals 3. Let's write down the domain. The domain is x is between minus infinity and infinity, and the range is y greater than 3. In 29, we want the vertices and the foci of this ellipse. So let's start by putting this in standard form. Standard form requires 1 on the right-hand side, so we're going to divide both sides by 36. So here we have x squared over 9, and here we have reduce y squared over 4 equal 1. This is now in standard form. Now, because the larger number is under x, that means we have a squared is 9, or a is 3, and also our ellipse is going to be horizontal, and the foci will be on the horizontal and the x-axis. All right, and here we have b squared is 4, b is 2. So let's we don't have to graph this, but let's graph this. It's horizontal. Okay, here are the vertices, 3, 0, minus 3, 0. Okay, so these are vertices. That's part of the question. The other part is the foci. So let's get those. Well, we have our little equation. C squared is equal to a squared minus b squared. So that's 9 minus 4. So C is square root 5. And here are the foci. This is square root 5, 0. And minus square root 5, 0. So that answers the question. Foci, vertices. And here I want to do another log equation. So we're going to use our log properties to write this as a single log. That would be log base 2 of x plus 2 times x minus 1. Now let's convert this to an exponent equation. So we have 2 squared equal x plus 2x minus 1. Square this out. 4 equal x squared. And here we have minus x plus 2x. That's plus x. Minus 2. All right, let's set it equal to 0 and factor. Subtracting 4 from both sides, we have a minus 6 here. Okay, now let's factor. This is x plus 3, x minus 2, and that gives us that plus x in the middle. So we have these solutions, x equal minus 3 and x equal 2. But we have to remember that the domain of log is x greater than 0. All right. In other words, only things that are bigger than 0 can be plugged into here. So if we plug in minus 3, we're going to get a negative 1 here. And we're going to get a negative 4 here. So that's not a valid solution. If we plug in 2, we get 4 here, and here we have 2 minus 1, both positive, so 2 is okay. So only one solution, x equal 2.